We're live?
Yeah.
All right. JVM CLI programs with GraalVM. Take 2 for people in the room. Take 1 for people online. Hello out there. I hope we have at least one person watching online. I'm going to go a little bit fast through the first couple slides because I already covered them in the room. And apologies for the technical difficulties, but we are streaming now. So, my name is Ed McDonald, and I'm presenting, like I just said, JVM CLI programs with GraalVM. Couple advertisements for the company I work for, Solution Street. We are hiring. There are more details on the Novalug website. If you apply for any of our jobs, certainly mention my name, or if you don't want to do that, at least mention Novalug. That should get your resume to the top of the stack. And there's my email address. If you apply for a job that we've posted and you mention Novalug or my name and you don't hear back from our HR, contact me and I can nudge them a little bit. So. And at this same location, next Tuesday, we will be hosting another meetup, the Nova SART, which is the Software Architecture Roundtable. And the topic will be solving real-world business problems with generative AI. So that is Tuesday, 6 to 8 p.m. Again, these slides will be available on the Novalug website, so you don't need to take a picture or remember this. You can see the details there. Okay. Let's get started. So, why would you want to, if you have tools like Rust and C and Go and Perl and Python available to you, why would you want to write your CLI utilities in Java? Why would you choose the JVM? Well, the number one reason I can think of is your organization, whether you know it or not, already has thousands, tens of thousands, millions of lines of Java code. You can reuse that. You can also reuse the vast amount of open source JVM code, Spring, Hibernate. I know that's a trigger word for some people. I love it. AspectJ. We'll cover some of this later in the presentation. And more than any other platform that I'm aware of, it gives you tons of language choices. So you can choose to write your code in Java, Kotlin, Groovy, Scala, Clojure, or as I mentioned to the group in the room, ABCL is a common Lisp implementation in Java. And then also very interesting, and I'm not aware of any other language pairs that enable this, but you can do joint compilation, which is not cross-compilation. But if you choose to write your project in Kotlin or Scala, you will then be using the Kotlin or Scala compiler, and you can intermingle 2 languages together. So you can write Java in Kotlin in such a way that your Java classes live right next to your Kotlin classes, and they can depend on one another, and there's no circular dependency. The compiler resolves that.
Can you not do that with Groovy as well?
I don't know. I know for certain you can do it with Kotlin and Scala. You're right. I think you can do it with Groovy. It's, in my opinion, Kotlin destroyed Groovy, right? So, like, Groovy was great, and then Kotlin came along, and who cares about Groovy anymore? I'm sorry, Groovy. But yes, I think you can do it with Groovy as well. I know that you cannot do it with Clojure because I tried to explore that. And of all these languages, Clojure is, so Java, Kotlin, Groovy, Scala all have things like classes, and you know, there are warts where if you try to integrate the two, you'll have to solve some problems. Using Clojure and Java together is more warts. The Clojure is very much different than all the rest of these languages. I love it. They'd certainly learn it, play around with it, but.
So what about JPython or JRuby?
Probably could add those in here, yeah. You won't get cross-compilation, but I think those would also work. Those are also 2 that I've forgotten about because I prefer just to use Ruby or Python. But
you won't get joint compilation?
You can't write, well, you can't write Ruby classes that depend on Java classes and Java classes that depend on Ruby. You have to make a choice which direction. In other words, that's another good way to phrase joint compilation. With Clojure, for example, if you want to use Clojure in Java, you have to make a choice as to which one you compile first, and then the other one can depend on that one. But you can't depend in both directions. And that's what joint compilation is.
Okay.
Yep. By the way, please ask questions during. I don't care, and I don't have a whole ton of content here, so we'll see.
In that list, would Flutter also be in that list?
I don't know. I don't even know what Flutter is.
That's kind of like a phone tech, but like you mentioned, Kotlin.
Is Flutter a JVM thing?
Runs in phones. And probably.
No, it runs on Linux too, because the new Ubuntu installer, I think, is
So
written in Flutter. But
I mean, its main selling point is that the winding library stuff for phones and stuff, you can just write it once instead of dealing with whatever the one for Apple is and what one for Android is. You can just use one and you don't have to worry about it. So
What
maybe that's 2 layers too high. So.
It might be a library.
Yes.
I think.
So 2 points there. What I would say is if it has a compiler that happens to be shipped as a jar file, that is a good chance that it will work. However, if it is a platform that Graal can't build native binaries for, then it definitely won't work. So, and I don't know if Graal supports, I mean, it supports ARM, and I don't know if it supports phones, which may or may not run ARM. I'm not sure, so.
Just curious.
Yep. Okay, so we talked about why you would choose the JVM, so why would you choose GraalVM? Well, you can be just as cool as the Go and Rust people and their native binaries. You don't have to listen to them anymore tell you that your language doesn't support native binaries, because now it does. Andy.
are they statically compiled native
Yeah,
binaries?
we'll talk about that. Yeah, we'll talk about that. Actually, I'll mention that now so I don't forget. I was talking with some people outside of before that started. This laptop that you see is my baby, and it never leaves my house. It makes me very nervous to do it. I usually present on another laptop because this one was very expensive. I don't want to spill coffee on it or anything. The whole reason I brought it here was because my other laptop is an Intel, and if I had compiled on it, it would have said it was an x86 64 binary. I actually have a command that I wrote just for Andy so that he could see that when I run Graal, the binary is an ARM 64 binary. So, so there's not, and this is a point that I should make, joint compilation is different from cross compilation. So the JVM, some of the Scala, Kotlin, maybe Groovy, we're still wondering about that, support joint compilation. Graal itself does not support cross compilation. So if you want a native binary for your platform, you have to build it on that platform. Graal has to support that platform.
So is like GraalVM still a Java virtual machine? So is the code still compiled to either Java bytecode or just like native machine language?
I don't know exactly. What I do know is that Graal is just another JVM, so you can run it as a JVM, and it will produce jar files if that's what you want. If you ask it to produce a native binary, it produces a native binary. So I do believe that that is machine code. It probably has the entire JVM loaded in the machine code, but you'll see when I, so the binary that this has produced, I'll run the file command on it, and it will tell you that, hey, this is an ARM64 native binary, and it will just be one file.
And
So
it includes all the Java libraries.
it includes everything it needs to run, yeah. So that probably includes like the actual JVM. So it's probably bytecode, and it probably has like a chunk of that file that is just Java bytecodes that then get fed into the JVM. I don't know the exact details, but the reason I think it has to work that way is because in this project I'm using Spring, I'm using Aspect-J, and I don't think that the Graal team has carefully created analogs of actual machine code for each of those libraries. It probably just takes the bytecode, dumps it somewhere in the executable, and then, yeah, just. Okay. So now some gotchas, some pain points that you're going to run into when you try to compile your code with GraalVM. The big one is GraalVM, when it builds your project, it does static analysis, and it gets rid of things that it thinks aren't used. So if you have a jar file that you depend on that has a class that has 200 methods in it, and your code only calls one of those methods as determined at compile time, not at runtime, Graal will take 199 of those methods and throw them away, not even put them in the binary, because it knows that they're not used. And if we have time afterwards, if people are curious, I will compile this. So I've already got the binary built, because I didn't want to make you guys sit around for 2 minutes while I build it again. You can see the output where it tells you, like, hey, I analyzed, I don't know, 10,000 classes and blah, 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 blah. So it gives you some metrics on what it's actually doing, which is why it takes so long to compile. So why is that a problem? Well, if you used any amount of Java, you know that most of the frameworks are heavy users of reflection, and reflection is discovery of methods that should be called at runtime, not at static analysis. So Graal doesn't see any of that stuff. So how do you fix it? Well, the Graal team maintains a lot of metadata for popular frameworks. So I briefly just want to show this. So this is the Graal source code, and here's just a list of projects that they as part of the distribution that they maintain metadata for. This again, there's a link to this in the slides. I just want to look at one. So here's Hibernate. If we come in here, Hibernate core, a version. These are what these metadata files look like that you feed, and don't hurt your eyes looking at this, but this is the metadata you provide Graal at compile time, and you're free to write these yourself. I actually had to write some to get this to compile, and I'll show that. But you don't have to look. All these say is like, hey, for this class, include these methods. Sometimes include all of them, regardless of whether you detect that they're called at compile time or not. Just leave them in the binary. Don't throw them out. So you can tell Graal how to do that. And possibly an anomaly for the Java world, Graal actually generates really useful error messages. Like if you run your code, it will tell you like, hey, I tried to call this method and it's not in the binary, and then you can just go add it to your file. So that's actually pretty helpful. I'm trying to think, there's something else I want to say there, but I think it's going to come up later in the slides. Okay. My personal soapbox about command line utility. So what is a command line utility, right? I have very strong opinions about this. If you write a tool and you call it a command line utility and you want to be a good citizen in the Unix world, which means lines in and lines out, number one, your command line utility outputs new line separated records. It only outputs records to standard out, no field headings and nothing else. And the reason I call this out is if anyone here uses Docker, if you do Docker PS, it outputs field headings. And that infuriates me because I have to write an extra grep command to knock out the field headings, because very seldom when I run a command am I not piping it to another command, and I don't care about the field headings because they don't tell me anything about the containers. And the other reason I mention this is anyone here who has ever used Java does not believe that Java is capable of this, right? Like you certainly believe that you're going to see a lot of extra garbage on the output when I start running this demo. So just keep that in mind. All right, so what is a record? Well, a record is white space separated fields. No intra-field white space, because I'm splitting on white space with one exception in the last column. And what does that mean? That means if you have a record that has multiple white spaces, you can put as much white spaces as you want in the last column, because when I'm parsing it, I'm going to take the first n-1 records and lump everything else into the last record. This is why when you run ls, now that Linux allows spaces in file names, the file name is the last thing, because you can take the first n columns and then you can just take whatever's left and know that that's the file name. So these are what I think the rules that make you a good CLI citizen. However, to show that I'm not an old curmudgeon and I can change with the times, I will make one exception to all these rules, and that is your command can output JSON, because I think probably the best piece of software written in the past 10 years is JQ. Maybe it's older than 10 years. I don't know. So JQ allows me, if you generate output in JSON, to follow all these rules, regardless of what you output. So if you don't know what JQ is, definitely check it out if you like CLI, especially nowadays. Yeah, I would say 50% of my job is writing curl and JQ command lines nowadays. So
how do you represent absence of data?
TBD, I don't know.
The word's TBD.
No, just no lines, no lines, right?
Before you move on,
Yeah?
I do have a question, because one of your sources cited on one of the previous pages. Exactly how involved is Oracle with the GraalVM?
Very involved. So that is a, yeah, that is,
I was afraid you were going to say that.
yes.
Oh, there's the lead. I did not know
Yeah, actually, yeah, my apologies, because I meant to mention that and I forgot. That is a risk, right? So Oracle owns GraalVM, and it's my belief is that the license currently says that you can use it to do whatever you want, but Oracle owns it, right? So,
Did they acquire it, or did they actually build it? It's like
well, they own Java, and then they built GraalVM. I think they built it. In other words,
Is it open source?
I think so.
That's not Oracle.
Yeah.
I mean, it's like GitHub.
Yeah.
So technically, MySQL is still open source. right? Technically.
But that is a good question. I don't know if they inherited it from Sun. I don't think so. I think this is an Oracle
Well,
thing.
Graal, they definitely did, because it didn't exist when Sun happened.
Yeah.
But
So
so like sometimes when they acquire stuff, the rules are a little different, I suppose, when they develop. And this is just my view from the cheap seats. Like
Yeah.
I said, I understand about as much about Oracle's business, you know, and how they've done things as much as the next guy.
So it says, Google
Google.
says that there is the community edition is open source, but there's
Oh.
an enterprise edition which requires blood from your firstborn or whatever.
Proprietary with more features.
yeah, if you use the proprietary version, Oracle will come and ask you, how many of these have you written?
Or you can use it for commercial, because isn't that what MySQL always do that?
Apparently, it does have its roots in Sun.
Oh, okay.
Is it has its roots from Maxine virtual machine, for anyone old enough to remember that stuff.
Careful.
I
Saying
don't
was
remember that.
old enough to remember it.
What are you talking about, Tim?
Yeah.
Okay. All right. So now the demo. I want to talk briefly about. Like I said, I created this project to write as little code as possible. I wanted everything to fit on a screen, so when I show it, but to use as much crap as possible, right? So I'm actually obviously using GraalVM, obviously using Java. As I mentioned, I'm using Scala, so I have joint compilation. I'm using Pico CLI, which is if you want to write command line utilities on the JVM, with the exception of probably Clojure and ABCL, because Clojure does its own way for everything. But you know, for the big ones, for like Groovy, Scala, Kotlin, Java, Pico CLI is definitely a library you want to look at that makes writing CLI programs really easy. I'm also using Spring Boot, Hibernate, H2, which is an embedded database, and we'll show how I use that. Liquibase, which is like a database migration tool, and AspectJ, which is aspect-oriented programming. And that is why I put the enterprise grade CLI, because if you're going to do Java, do enterprise grade, right? Use all the things.
So have you done any Kotlin stuff like for this?
At Aaron, I did, but not for this. No.
Because Kotlin has the Click library, which is really cool.
Oh yeah. So this Pico CLI will also work for Kotlin, but Kotlin also has clicked. So, oh, and actually there were some other things I wanted to say. Oh yeah. So keep in mind when I demo this, when I run these commands, in the background, this command is initializing Spring. It is determining whether a database migration needs to be performed, and then performing it if it needs to be. It doesn't need to be because the database already exists. And then a database connection is created, right? So all those things are happening every time I run this CLI. And there was one thing I wanted to mention. On Java projects where I'm not allowed to also use Scala or Kotlin, or where I'm told I have to use Java, one of my absolute favorite libraries to include, and this is very divisive, is Lombok. I love it. Yeah, I love that face Andy gave me. I love it, and I highly recommend it. And if you ever work with or for Andy, definitely use it without telling him. It's amazing. The reason I didn't use it here is not because Graal prevented me from using it, it's because Scala prevented me from using it. So when you use Scala or Kotlin, you're using the Scala or Kotlin compiler, and they delegate to Java compilation. Lombok plugs into the Java compilation process in a way that is not enabled when Scala or Kotlin delegate to it. And the way it plugs in is it uses like preprocessor annotations. Kotlin is very amazing. Kotlin is very amazing. Lombok is also very amazing. And they do some very crazy things to let you write modern Java code.
The reason you use Lombok is because you can't use a better language. That's the whole reason you have to use it.
That's exactly right. And so that's in my notes here. I put, so like Scala versus Lombok is a fair trade, right? Like I'll take Scala over Lombok, but if you hire me to work on your team and you tell me I can't use Scala or Kotlin, well then Lombok is going to sneak into your code base. So you've been warned. Okay. So I have a make file. It's going to echo the commands that it actually runs, but I script all this so that I don't have to worry about remembering the commands to run. The first one I'll show you, which is the one I told you about. So I'm going to run, I'm going to say, so I use Gradle, so that's why there's a build directory. And then the GraalVM creates this directory structure underneath. When I ask GraalVM to create a native binary, it puts it in native compile. So I'm just saying, find me all of the things in this native compile directory, and then run the file command on them. So this is going to prove two things. It's going to prove that there's only one file in there, and that it's an ARM64 native binary. So that is what was produced. Now, if you run this on Linux, if you build this on Linux, when I did it on my laptop, I got more than one file. I got SO files, which are dynamically linked libraries. I'm guessing that there is probably a Graal option that asks you to statically link them, right? So, but whatever, by default, the GraalVM on Java can produce multiple binaries, one of which is the executable, and others which are dynamically linked libraries. And I'm guessing the reason they do that is maybe they take things like Spring or whatever and put them in SO files. No idea, but yeah.
So when you copy around the binary, do you have to copy the SO file with it, or?
I'm guessing you probably have to. And actually, I said maybe they put Spring in the SO files. That's probably not true. They probably actually put the JVM in the SO file, but I'm not sure. So.
So it's more of a deployment question, because a lot of times you compile it here and then shove it wherever.
Yeah.
What bits are you shoving to have it work?
So you would definitely need the SO files. I mean, the whole reason SO files exist is because presumably they can be. I'm speculating here. They separated them out, so maybe they're assuming that whatever your deployment target is already has those SO files, in which case you could just copy the binary over. But I think that's just based on my knowledge of SO files in Linux. I'm making guesses here. So, all right, and now, so before I run this command, this is going to tell us how big this thing is. Remember, if you do this for LS on your local machine, you're going to get a couple kilobytes, whatever. This one comes in at 138 megabytes. So remember, though, we have Spring in there. We have a whole ton of Java libraries. Yeah, so.
That's not that bad.
Yeah, I mean, I've given up on optimized binaries, right? So I'm happy to buy more memory. This laptop has 64 gigs of RAM. When I buy a new one, it will have 128 gigs of RAM. Yeah, we've lost that battle. No one writes optimized binaries anymore. That's another rant. All right, before I run the next demos, I just want to show you this so that people don't think I'm pulling any tricks. I didn't want to type, so on line 27 here, I didn't want to type build native compile JVM CLI. So I wrote a script that initially started as just line 27 here that essentially lets me call that and just pass it a bunch of args. So I don't have to type that whole thing. Then this script evolved into something that also lets me pass a -v flag, and that -v flag, if passed, sets two environment variables. And we'll talk about what they do later, but this is a way, well, I'll talk about it right now. Spring configuration, you can provide Spring configuration in multiple ways. One of them is with environment variables. So when I pass -v, it passes some configuration to Spring. I will call that out when we demo that specific instance of this, right? So for most of these, all I'm doing is calling JVM CLI. Sometimes, one time when I demo it, I'm setting two environment variables. So there's no magic in this run file. I didn't think that people thought I didn't want people to think I was pulling punches or anything like that. So, okay. Yes?
I don't know if this was mentioned earlier. I think GraalVM has an open source version and a enterprise
Okay.
version. Yeah, C versus.
Okay. Yeah. So,
Yeah, we kind of brought this up earlier
Yeah.
when we were talking about the Oracle side of things.
yeah. Okay. And again, it is Oracle, so there's a risk there. But yes, Oracle has not managed to destroy the JVM OpenJDK. So I'm not a lawyer. I hope that the Open Graal is operating under the same constraints as the OpenJDK. So, all right, the next thing to demo. So I'm just going to run this command. So this is as if I typed -h. So So this is just to prove a couple things. Number one, it generates, it's self-documenting, right? So it generates, I asked it for help, it generated output. We see a couple things that, so we'll get more into this in the demo, but the command I wrote, it has subcommands called filesys and history. Yeah, I'll get to that in a second. It has filesys and history. Each of these has subcommands. So filesys has ls and find, and I'll demo those. And then here's how long it took to run. Almost a second, but once the cache gets warmed up, I'm going to run it again. This is more reasonable. So now it only took 1/10 of a second to run. I've seen it go, it hovers around 1/4 of a second once it's loaded in memory. This is actually faster than I expected, but don't judge it by the full second. But I still think that a second is better than anyone thought that this would take in here. So, and we'll run some more sophisticated commands. So that was D1. So now, like I said, so this is, Pico CLI lets you structure CLIs with commands and subcommands, kind of like Git has subcommands. So you can package a whole bunch of stuff into one big CLI, which is one of the reasons that these binaries can get pretty big. So I wrote a command called ls, which does exactly what you'd expect, and we'll look at the source code. But I just want to show you that when I run it, again, 1/2 a second, and I just showed the first 10 items because I wanted everything to stay on the screen, which is why I piped it to head. Again, another, like I said, anytime I run a Linux command, it is very seldom that I'm not piping it to something, which is why I had all those rules in the beginning. And then I have another version of this that I did a -L flag, and we'll see that we get, this isn't exactly what you would see if you ran ls-l, because this was what was easier for me to write, that it would fit on a single screen, but I show the permissions, the owner, the group, and then the file name, and that took 2/10 of a second. And that was the third part. And now I want to show you that I also wrote find, and when we go into the source code here, you'll see that one of these is written in Scala, one is written in Java. And find, my find is not very complicated. It just walks the directory tree and shows you that it does it recursively. I don't evaluate expressions or anything like that.
That's just free at that point.
What's that?
That's just free at that point.
Yeah, it's tree. I could have called it.
Fancy-ified with all like the branches and whatnot, but yeah.
Yeah, you're right. I could have called it tree, but yeah. Again, 2/10 of a second, a little more. And yeah, so before I run this command, I'm going to show some code. So how do we organize this thing? So like I said, I'm using Spring, right? So this is what a Spring Boot application looks like. This is the Spring bootstrapping. This is boilerplate. You say it's a Spring application. Import runtime hints. There's actually 2 kinds of runtime hints in this project. I'm not going to talk about these because I don't have time and I don't remember why I had to do it, but it was one of the things to get it working with Graal. But the important part is most people, when they think of a Spring application, they think you start it up and leave it up and it attaches to a port somewhere, right, on your, you're writing a service. However, Spring also lets you create command line runners, and so the whole Spring application bootstraps. Like I said, when I was running that, and we'll show this with the next command, when I was running that, we're going through a whole Spring bootstrapping, and all of that takes, all of that is rolled into that 1/4 of a second that we're seeing. The way I make this a command line app is I implement a command line runner class in Spring, and I make it a component so that Spring can discover it. So when Spring bootstraps, it brings up the whole Spring environment, and then it goes and looks for any command line runners and runs them. If you have multiple, it will run multiple of them. But since I want a single program, I just create one command line runner, do some Spring boilerplate here. I inject a class called main, and then I call main get command line, which returns a Pico CLI command line object. And from there, it's just Pico CLI. Pico CLI, the API, is say, do whatever you need to do to create a command line, whatever that means. Once you have one of those things, call execute on it and pass it the args that were passed to main. And because I'm a good command line citizen, whatever Pico CLI returns, that's what I call system exit with. So if Pico CLI returns something non-zero, I exit with a non-zero exit code. That's another, that wasn't in my CLI rules, but your system exit code should be meaningful. And if people don't do a lot of CLI programming, it's one of those weird cases where 0 means success and everything else means failure. But so what is main? Because I'm using Spring, I used Spring, right? So main is a component, and this command line right here, this is a Pico CLI annotation. So this contributes to the help documentation. You see I give it a name. Mix in standard help options are what tells Pico CLI, like, hey, give them a -v and a -h option. You don't have to write them. I'll write them for you. That's why when I run -h, Pico CLI essentially takes all of the documentation I have in the annotations and generates that help message for you, like this description right here. But since this is a Spring component, I've architected a way to build the whole subcommand hierarchy at runtime. So when Spring finds this component, it will inject main subcommands into it, which is an interface that I chose. So anytime I define a command that has subcommands, I say, hey, give an interface. It's just a marker interface. And any class that implements this interface will be found at runtime and injected in here. So again, that maybe doesn't make a lot of sense to people who don't use Spring, but instead of in the code statically building this whole architecture of commands and subcommands, I'm letting Spring do it for me at runtime using so that's why you would want to use Spring in your command line CLIs.
Oh, to obfuscate the code. Okay.
Yeah, to decouple it is the word that we use in the biz, yeah. This parent command is what main extends, and this method implements all the magic. I'm only pointing that out so if you look at the source code, you can see how I'm using Spring to build that hierarchy, but that's too much detail for here. So let's look at the filesys command. So like I said, this is the filesys command. It has two subcommands. Because IntelliJ navigates this code for me, I can click here and say, oh, what implements it? We'll find an ls. So I'll look at ls. And now we finally get into the real meat of what's running this behind the scenes, right? So again, command line, command annotation. This is a Pico CLI annotation. This is a Spring annotation. This is Pico CLI. I'm saying, hey, this command that I'm writing, it takes one parameter, which for ls is the directory name. When you're done parsing the command line, if you could please put it into this variable for me, I would appreciate it. And then you also tell Pico CLI, hey, I'm expecting a flag, and it can be either -l or --long. When you parse the command line, if you find it there, set this Boolean to true. Otherwise, just leave it false. So again, Pico CLI is doing all of that command line parsing for me just based on Java annotations that I specify. Now I can write the meat of the actual code, again, assuming that this directory and long out, if I made it this far, they've been set. The command lines was successfully parsed. And all I'm saying here is, hey, create a file, which is and then list all the files under that file. So in Java, file and directory are the same thing. Once you create a file object, you can list the files underneath it. And then I'm looping over. And for each one, if this long output flag is not specified, IntelliJ keeps obscuring stuff. Just print the file name. Otherwise, do a whole bunch of work to translate your representation of permissions into a nice RWX string. And then, by the way, print out nice printf formatted. If people use printf, they may not know exactly what that means, but they'll have some idea that that is formatting it into columns. And then print the permission string, the owner, the group, and the file. So that was a lot. Any questions? Blah, blah, blah. Here's how you do it in Java, right? Perhaps more interesting is, that's a little bit painful, right? I mean, Java is kind of verbose. So the find command was actually written in Scala. And this is the find command in Scala. Because you have to use annotations in Java libraries, it still tends to be a little bit verbose. But here's the recursive, just list all the files in the directory. This is just to prove that you can write this in Scala. A couple things about Scala, if you haven't used it before, is the code tends to be more concise, which is nice because they let you put multiple classes in the same file. So I actually have another command implemented down here that's part of the history subcommands. And we'll get to that in a second. So, all right. So when I said that I could pass my wrapper script a -v flag, and it is going to set some Spring variables, some Spring configuration options, the two options it's going to set is it's going to say, hey, before you run this command, let Spring know that I want to see logging output, and because I'm a sadist, I want to see it at debug level, right? So I think personally that when people saw that I was going to be presenting on Java CLI, this is what they expected when I ran CLI, right? So, so this is Java. And I mean, to me as a Java programmer, this is beautiful, right? I love it. More information is always better, right? So if we come through here, we see Spring starting up. We see, where?
Beauty is truly in the,
Yes. Here, Hikari, we see the database connection pool coming online. Oh, this is great stuff. And then we see Liquibase coming online. And then, where is it? Wait for it. Oh, Hibernate joins the party. And then it's Hibernate, 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 some exceptions. It's great. But they were logged at the debug level, so it's fine, right? It's just for your information. Hibernate, 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 Hibernate. Wait for it. Don't blink. Here it comes. More Hibernate, more Hibernate.
we're going to get the output finally.
Yeah, that's what we're waiting for. Don't blink. You're going to miss it. Oh, there it was. Here's your output for the command, right? Great. I'm just showing you this to prove that you can hide it, right? So you don't have to worry about this. You don't for your information. This is helping you out. Do you really want me to go dig into it?
You said that it should have valid exit information. You didn't say how much or how little.
I mean, you've used Hibernate before. You know that they throw exceptions that are just warnings, right? Like the Hibernate is,
Oh, yeah.
yeah.
It's a wonderful library.
Hibernate is lovely. I love it. It's the best stuff. Yeah. All right.
Java exception, I don't think I've ever seen one of those.
Can't see if you don't use Java.
It's the best way not to
Okay.
Not to use Java.
I grep through the exceptions and look for the ones I can actually use.
You can't. So, grepping exceptions is also painful because you only get one line of them. So,
Like the header line, and to be fair, other developers on troubleshooting logs would have been a little easier in their code.
So here I'm just showing that if I run it with garbage, that it actually tells me like, hey, you ran me with garbage, right? And this actually, I believe, now because I've wrapped this in time, this is doing it live. I don't know what this is going to return. I don't think it returns what I want. Oh, it does. Okay. So it actually gives if you do something that is an error, Pico CLI will tell you, it'll give you nice red lines there and say, foobar, fizzbuzz, baz, I have no idea what you're talking about. And it'll also tell you via the exit code that, yeah, I don't know what you're talking about. Like you did something wrong. Like, yeah, so.
Those are well-behaved citizens.
Yeah, yep. And I think this is the last demo, and then we're going to show a little bit more code. Okay, so all this time I've been saying we're using a database, right? So why are we using a database? Well, there's a history that this maintains for you. So this command, really you only need to pay attention to this.
The Perl part?
No, there is definitely Perl in there. I mean, all the languages. Yeah, I love Perl. I seriously love Perl, people. Learn Perl. Really, this is all you need to pay attention. All the other garbage is, in Linux, it's very easy to get the first n items or the last n items. But if you want the first n and the last n without having to run the command twice, you have to jump through some hoops like that. So that's the only reason those are there, is because I wanted the output to fit on the screen, and I wanted to show you that the count starts at 1 and it ends at 37, because that's how many commands I've currently run. Not during this demo, but in the time since I've destroyed the database. But yeah, so you can see that, like, these are what we've been running in the demo, right? It takes less than half of a second to run. We have a history. So the database, right? Why would you write an enterprise Java CLI if you couldn't have a database? So how am I doing this? Well, no, it's H2. It's H2 is an embedded Java database. Yeah, so it's all Java all the way down.
Does he work for Oracle?
I worked for Andy once, and then
Are you Oracle?
he did make me learn Kotlin, to his credit. So, Um,
Would have diverted the shop to Rust, but
it didn't exist yet.
it did.
Oh, it did?
Yeah, that's what's
Okay, so in commands.scala, so here is the command that shows the history, right? This is the shortest one of all of them. So what does it do? Well, remember, it's a Spring component, so it gets injected into it a command invocation repository, whatever that is, right? But a command invocation repository is something that you can call find all on, and then use some Scala magic to index the whole thing, and then you can jump through some hoops and print it out with the line number, which is the index, and then a nice formatted what the command is you run. So I don't want to go into too much detail. The point here is that this is actually a very little bit of code. And then the second point is that this command invocation repository is something that Spring generated for me. So if we look in this repositories.scala, anyone who's used Spring keeps getting more and more advanced. When I learned about this, this was really weird for me. It turns out that this has been around in Spring forever. But in Spring, if you implement a JPA repository or a list CRUD repository, you get a whole bunch of stuff for free. One of them is like a save method, which you'll see in a second. But also, it does some crazy stuff where if you write this method, this is just an interface. And at runtime, I ask Spring for an implementation. I don't provide the implementation. Spring provides it. And it looks at this method name and it says, oh, he wants to find something by ID, and the thing he wants to find is a command line invocation, and ID is big integer, and this is enough information. It essentially makes a DSL out of the method name and generates the implementation at runtime. Same with find all too. That one's a little bit easier, but these, it has like a syntax for these things. Find by ID. You can do find by last name if the thing you're looking for has a last name field, and it generates that code at runtime. So it's really, really magic in a way that I kind of don't like, but hey, I'll use it, right?
Does it only do it for JPA, or does it do it for native SQL?
It's a good question. I don't know. I probably just JPA because it has all that information in the annotations and stuff. It probably can't do it for SQL. And that's a good segue because when I say all that information in the annotations, hey, Hibernate, right? And actually, this is not Hibernate. This is, what's the standard called now? JPA. It's Hibernate under the covers because I know that Spring uses Hibernate, but these are all JPA annotations. So these are the entities that I've defined, command line invocation and command argument. Because this is Scala, these look much smaller than they would if it was Java, and I can put two of them in one file, so it's kind of neat if you're a Java programmer. Another reason to use joint compilation. And finally, something for the DBAs out there. So like I said, there was a database. We can actually run queries against it. And so here we see, so I selected I selected from command invocation, left join command argument. So that's a one-to-many relationship. And I take the command, which is the actual JVM CLI, and then I call array ag on the arguments, so I get them all in one line, and I get output that looks like this at the bottom. So this is the equivalent output that was used to generate the history that you saw. And just to convince you that I'm not pulling punches here, this is actually the same database. We'll just run a count, 37, and that was how many lines I output on the last slide. So I think that's probably enough looking at code. Almost just wrapping up here. So in summary, why GraalVM? You get the entire Java ecosystem. You get a single binary. Again, on Linux, maybe multiple binaries unless you figure out how to wrap it all into one. And I hope I've proved to you that it's a fast startup for Java. I'll come back to questions. Just wanted to shout out to some peripheral tools I've used, which I did say some of which warrant their own presentation. So I assume Andy will be talking to me afterwards. All these slides were created using LaTeX and Beamer. Highly recommend them. If you check out the code repository, we'll talk about that in a second. Also using Gradle. I have a love-hate relationship with Gradle. I love Maven, and I know that's old school, but Maven makes more sense to me. Gradle does more, changes a lot. Yeah, it's frustrating to use. most of this Gradle was written with the help of ChatGPT, so I have it write it, and then I try to understand it, which eventually I come around and do. So the GitHub repo, so you could check it out. And do check it out and try to build it, because I'm curious if it works for you. So in the GitHub repo, you need, have people heard of ASDF or SDKman? Yeah, okay. So I use SDKman. In the GitHub repo, I have configuration files for both. The ASDF, I tested it a long time ago. The project has evolved since then, so I'm not sure if it works. But long story short, I use SDKman. I can check this repo out. I can go to the root repository and type SDK env install, and it will install the proper version of the GraalVM. And then I can just type make, and it's GNU make, because I used one feature that requires GNU make. If you're on Linux, you already have it probably. If you're on Mac, you need to maybe separately install GNU make. Or you can just open the make file and see what the command I run is, right? So really, you only need two pieces of software to build it. You need SDKman and make. I use the Gradle, what do they call that? The Gradle, basically I use the Gradle bootstrapper. So when you type make, it will type Gradle bat if you're on, yeah, the Gradle wrapper, which is a Gradle script that will download Gradle. So you can really just type SDKman env install. It will install GraalVM, or if you use ASDF, whatever the equivalent command is, and then type make, and it will build the whole thing for you. And I'm curious if that works for you.
Or you can use brew and do it all in one place.
Don't do that. Also, there's a presentation directory in there that has all the LaTeX slides. And in there, if you have Docker installed and GNU make and you type make, it should build the whole presentation for you. After it downloads a 2.5 gigabyte Docker image that includes the whole LaTeX environment, right? So you don't need... Yeah.
2.5 gig container.
I've...
Work image.
That is small where I work now, so yeah. I mean...
Okay, I'm going to ask the obvious question, which is this they just took a VM and shoved it into a image?
LaTeX is a whole platform of its own. So it, and you don't, you are free if you are experienced with LaTeX to install LaTeX, and I think
Are we talking about latex?
it's pronounced, yeah, it's pronounced LaTeX, but
It is.
yeah,
It's
I've been calling it latex.
yeah.
Okay, I mean, maybe I
guess I'm not the only
like, is this like toilet and toilet?
No, so
Like when people
I
have
believe-
really, really dirty names, but they try to add a French thing
no,
to them?
if you Google how it's pronounced, there will be a document out there that will tell you that this is not an X and maybe this is not an E. Like this is the,
Okay, so
yeah.
we're in Bizarro.
Yeah,
world.
yes,
Gotcha,
yes,
gotcha.
yeah. Yeah, it's Greek letter chi, and like so. Yes, it is latex. I'll know what you're talking about if you say
Oh, wait a minute,
latex.
is this more like a Cerberus situation? Like,
No,
I'm generally asking this because I have to correct people at work all the time. They keep calling it Kerberos instead of Cerberus.
oh, I would have said Kerberos. So
So Cerberus is spelled after the Greek spelling of Cerberus, which starts with a K, not a C. But I've never seen X pronounced as a K.
this is
Say
yeah.
latex to me, I think of the text technology, so, there we go. Oh, this isn't that. No. It is. Oh, I was
Wait,
like,
what?
because I was like, why would you need all that just to write latex? Okay.
So,
No, I think he said
Now
that
I'm
was
really
for
lost.
doing this presentation.
Yeah. So I mean,
Oh,
we could take a look at latex code, latex code.
like,
I
okay.
do have a question about the startup.
I
Have you
got-
tested this on slower machines?
So I did test it on my 2013 MacBook Pro, which is running Debian. So yeah, and it was still under a second, if I recall correctly.
What about a
But-
1 gig Raspberry Pi 3?
Well, I mean, it's going to eat up 138 megabytes just to put the thing in memory. So there is that. I mean, remember the size of this binary was 138, and I don't know enough about CPU architectures to explain exactly why, but when I run it the second time, it's about twice as fast as the first time. Yeah. Yeah.
File caching.
And is that actually the resident set size, or is that just
No, that's just the size on disk. So
Yeah.
it could be larger in memory.
Yeah.
smaller?
Unlikely, but yes.
No job.
but this is LaTeX code. So this is the actual presentation that you've been looking at. So LaTeX. LaTeX is for people who haven't heard of it. It's a markup language that is also a programming language. It's like a Turing complete HTML kind of. So yeah. But Donald Knuth wrote it because he couldn't typeset the math books he wanted to write the way he wanted to typeset them. So he took a couple of years off and wrote LaTeX, which is still around and still in active use. It produces PDFs, which are the most portable document I've encountered. I like them. So, yeah, I mean, I don't love Adobe, but PDFs they did right. I can take a PDF that I have from 20 years ago and double click on it, and it still opens. That's not true for a lot of technologies out there. So,
Plain text files.
yeah, plain text, yeah.
So is this basically just an alternative to using Markdown and some kind of
Yes.
generator with it?
Yeah, but a lot of published books, especially mathematical journals, are written in LaTeX. So it's much more advanced and it gives you a lot more options. So professional publishers use it. I think maybe, all right, I'm just guessing here, but I think O'Reilly has a LaTeX template that they want you to use if you publish for them or stuff like that. So it's used for those types of things. But with a plugin called Beamer, which is the other thing I mentioned on that slide, you can actually generate slides for presentations. And since I'm selling LaTeX here, tell me if I'm talking too much. When you run that command, when you build a presentation, it'll actually produce 3 files. One will be the handout that you find on the Novolog website that I sent to Andy and he posted, and that just takes all the transitions and compresses them into single slides so you don't waste paper. It will also produce the presentation, which has like a different page for every bullet included so that I can just skip through and looks like bullets are coming in. And then it also produces one that's double wide and has a whole separate set of notes which you can share on another monitor. So when I'm presenting up here, I see the notes that you don't see up there. It's one PDF file, it's double wide. I use software called PimPress, which is a Python program, open source, that knows how to handle files like that and show the other one on a second monitor. So that I get this, little timer down here, how long I've took, the current slide, the next slide, and then any notes I've taken. But I haven't listed any notes for this slide, so.
But your actual content for the slide is in what? Just straight up text? Or is it in text?
It's in LaTeX,
It's in
yeah.
this
Everything.
So it's like Markdown.
Yep.
Oh.
I think we found our January topic.
The very first time, because it's Java, you have to download the internet. So Gradle will download a whole ton of stuff before it even starts building. And then once everything's downloaded, I've found that Graal takes about 2 minutes to compile it on my machine, which is a beast.
Didn't you say you tried it on your like 2013 MacBook?
Yeah, I can't remember how long it took though.
Was it a lot longer?
Possibly, it's still going.
Yeah, it's like 19 minutes for me.
Holy
On the-
shit.
on the compiler. yeah, like.
Compile or download?
No, it's on compile. I'm on compiler now.
Oh, and you got past the downloading the internet.
Yeah,
Okay.
that wasn't that bad.
Okay. All right.
Yeah.
How old is that machine?
Probably like 4 years.
But if you want to see, he's to the point where it has generated the output, and it's like, I've done this. So it shows how many methods it analyzed, right?
I don't.
Inlining methods, compiling. Oh.
Yeah,
Example repo doing that?
yeah.
Yeah.
Practicing restraint. Andy's practicing restraint.
All right, that's it for me. So.
Now you know why I keep rust. Anyway. Thanks, Ed. Very good presentation. Sorry. Very good presentation. Remember, we're going to try to. Remember, we're going to try to go to Charcoal Kebabs after this. And the other thing, which I forgot at the beginning, I have the Novolog stickers. So I'm going to put them up here, and you guys can take as many as you want. Anything else? Anything else we need to cover? None? All right. Thanks, everyone.
Oh, that's fine. Ubuntu image. I'm wondering if it was Ubuntu versus Alpine for the presentation image.
Since we're done, I'm just
It's
going to
part
build
of
it
the
on mine and see how long
Alpine
it
image.
takes.
It's like really small. Yeah. No, it's using Ubuntu, which is